a wanderer enters. Across the ocean of darkness that envelops our galaxy, a solitary traveler cuts its way through the void. It does not belong to our sun, nor does it heed the gravitational pull of the planets that whirl in familiar orbits. It is a stranger, nameless at first, no more than a shifting speck upon the backdrop of stars. Yet within that speck, entire histories sleep, histories of alien suns, of ancient collisions, of forces too vast for the human mind to fully contain. This is not an object born of Earth, nor even of the solar womb that cradled our world. It is an interstellar guest, carrying with it a silence older than humankind. Astronomers speak of such arrivals as statistical inevitabilities. In the immensity of space, every star forms and discards, ejecting shards of its creation outward like forgotten fragments of some grand cosmic workshop. Most of these shards drift forever unseen, lost in the gulfs between stars. But every so often, against impossible odds, one comes near enough for human eyes to glimpse. That improbable alignment has happened again. The name we now know it by is 3I Atlas, the third confirmed interstellar object to pass through our system. But long before the designation, before the calculations and classifications, it was simply that, a wanderer entering unannounced. To speak of such an entrance is to acknowledge a profound reversal of perspective. For millennia, humanity looked outward to the stars, always assuming they were distant and unreachable. Now, one of those stars has cast off a fragment, and that fragment has come to us. It is as if the cosmos has sent a message in stone and ice, its meaning encrypted in geometry, speed, and reflection. Yet it speaks not in words but in riddles of motion. What secrets does such a visitor carry? What hidden story lies within its journey? It is a question that reverberates in the halls of science and philosophy alike. For in every wandering body is the potential of revelation. Each interstellar guest reminds us that our solar system is not an isolated island, but a port of call in a galaxy alive with motion. When such travelers appear, they force us to confront our fragility, to recognize that the skies above are not static, but a vast ocean in which we are adrift. And somewhere, out in that immeasurable ocean, is the place where 3 Atlas began its journey, a birthplace forever beyond our reach. In this way, the entrance of such a wanderer is more than astronomical curiosity. It is a mirror held up to our longing for connection, for knowledge, for meaning. The cold fragment drifting across our sky asks us quietly, "Do you understand your place in the universe?" It does not linger to answer. It merely passes, silent and indifferent, as all true cosmic travelers do. First glimpse. It began, as so many astronomical revelations do, not with a thunderclap of certainty, but with a whisper of light captured by sensitive instruments. On a quiet night, in 2019, the Atlas Survey telescopes, designed to scan the heavens for near-Earth objects, registered an anomaly. Amid the regular dance of asteroids and comets tracked daily, there was a moving point of light that did not belong. At first, it seemed ordinary, another icy fragment orbiting under the rule of the Sunday. But as the data accumulated, the strangeness emerged. Atlas, the Asteroid Terrestrial Impact Last Alert System, is no poetic oracle, but a tireless sentinel, its robotic gaze sweeping the sky for potential dangers. The irony is undeniable. A system meant to warn humanity of threats inadvertently became the herald of a cosmic visitor. Its cameras, tuned to pick up faint intruders against the overwhelming brilliance of the night, caught sight of something that defied expectation. The object appeared with a faintness betraying both distance and size, yet its trajectory was unusual, fast, skewed, and already hinting that it was no mere solar system body bound by familiar rules. Astronomers at first treated it with caution. After all, not every odd orbit announces a revelation. Many times before, comets with eccentric paths had teased of mysteries, only to yield to simple explanations. But there was something about this trace, something persistent in the data. The speck moved at a velocity too great for capture, its arc suggesting an origin beyond the sun's reach. The algorithms flagged it, the analysts checked, and one by one, the threads of doubt unraveled. To glimpse such a traveler is to peer into chance itself. The sky is vast, the stars are countless, and the volume of interstellar debris beyond comprehension. Yet here, on this one night, in this one sweep of the sky, human instruments intersected with a grain of matter born in another system. The first glimpse was not dramatic to the naked eye. It was a small digital echo, a set of coordinates, a dim signature against the black. But within that faint shimmer lay the promise of a story billions of years old, a tale that no telescope could fully read, yet one that demanded attention. In the days that followed, observatories across the globe turned their instruments toward the anomaly. The faint speck grew into an object of fascination. Its provisional designation was temporary, a placeholder until its nature could be understood. But for the astronomers who first gazed at it through Atlas's relentless scans, it was already more than data. It was the first thread of contact between our system and the deep unknown. Thus, the first glimpse of 3 Atlas was less a revelation than an invitation, a faint light across the void, beckoning humanity into another layer of cosmic mystery. With it, the sense of discovery was reborn, that childlike wonder when something not of here, not of us, brushes briefly against our world. Catalogued anomaly. In the language of science, discovery is never left untethered. What begins as a flicker of light across a detector must be named, logged, and folded into the living archive of astronomy. So it was with the wandering speck traced by Atlas. After the first nights of observation, its provisional designation was formalized, C 2019 Q4, Borisov. Later, when its true interstellar nature could no longer be denied, it received a title worthy of its strangeness, 3I Atlas, marking it as the third interstellar object ever confirmed by humankind. These letters and numbers may sound cold, yet they are a cipher for awe. The 3I speaks of sequence. First came Oumuamua, then Borisov, and now this. Each entry deepens the catalogue of interstellar visitors, a list that is still astonishingly short, considering the galaxy's immensity. Atlas, meanwhile, anchors the discovery to the instrument that first caught sight of it. The act of cataloguing, then, is not just clerical. It is an act of recognition, an acknowledgement that something beyond ordinary boundaries has passed into our awareness. As data poured in, the object's path revealed a truth no classification could disguise. Its eccentricity, a measure of how stretched its orbit appeared, was greater than 1, the unmistakable signature of an unbound trajectory. It was not looping back to the sun like comets do. It was on a one-way journey, a parabolic arc slicing through our system, immune to capture. To astronomers, such numbers are not abstract. They are sentences in the cosmic language, declarations that the object was not born here, not shaped by our planets or star. It was alien, not in the cinematic sense of spacecraft or beings, but in the truest astronomical sense, a piece of another star's story. The catalogue entry became a gateway to deeper questions. If this was the third, how many others had slipped past unnoticed, their faint glimmers lost in the infinity of the sky? And if 3 could be found in only a handful of years, then perhaps such encounters are not rare at all, but common, with humanity only now opening its eyes wide enough to notice. The act of naming 3I Atlas thus symbolized more than classification. It hinted at a shift in perspective, a dawning recognition that our solar system is less isolated than once thought. Yet behind the catalogued order lay unease. This anomaly was not only foreign but fleeting. Every hour carried it farther from our reach, every day diminishing the chance to study its mysteries. To log it in the record books was necessary, but also bittersweet, for the catalogue was the only permanence this wanderer would ever grant us. In time, it would vanish back into the darkness, leaving nothing but the trail of data etched into human memory. Tracing its path, once the anomaly was catalogued, astronomers turned to the deeper question. Where did this interstellar guest come from, and where was it going? To answer, they unraveled the mathematics of motion, applying Newton's laws and Einstein's refinements to the faint trail it had etched across their telescopes. The sky became a canvas of coordinates, and the object itself a moving brushstroke of alien origin. Each night of observation added points to its track. Computers calculated its orbit backward in time, seeking a source. But what emerged was not the familiar ellipse of a comet, nor the bound curve of an asteroid. Instead, the numbers resolved into a hyperbola, a trajectory too open, too swift, to be tied to the Sunday. Hyperbolic orbits are the signatures of outsiders, objects that enter and leave, never to return. And here was one drawn perfectly, a bowstring of mathematics stretched across the sky. Its velocity told the tale even more starkly. At over 30 kilometers per second relative to the Sun, it was far too fast to have formed within our solar neighborhood. No slingshot around Jupiter, no cascade of planetary nudges could have given it such freedom. Its course carried it inward past the Sun and then outward again, destined to cross the orbits of planets only briefly before sailing away forever into the galactic night. Tracing such a path is like trying to reconstruct the biography of a stranger from the prints of their footsteps on a beach. Scientists could say this: 3I, Atlas, had drifted across light years before intersecting our world. Perhaps it was born in the icy outskirts of some alien solar system, hurled free by the gravity of a giant planet. Perhaps it had wandered for millions, even billions, of years, its surface scarred by collisions with dust, its heart unchanged since the dawn of another star. Backward projections attempted to tie its origin to specific regions of the galaxy, but the uncertainties were immense. Over time, gravitational tugs from countless stars, invisible molecular clouds, and the slow oscillation of the Milky Way had altered its path beyond recognition. It was like following a thread through a storm possible only for so far, then lost to chaos. The best science could offer was probability, that it hailed from somewhere among the spiral arms, a child of a distant nursery whose name we would never know. And so, in tracing its path, astronomers realized they were not just mapping a rock's trajectory, they were sketching the line between here and elsewhere, between the familiar family of planets and the infinite wilderness beyond. Each calculation was a reminder: the cosmos is not quiet. It sends travelers across gulfs of darkness, emissaries of other worlds. To trace their paths is to acknowledge the wider stage on which Earth itself is only a fleeting actor. Echoes of Oumuamua. To many scientists, the discovery of 3I Atlas stirred déjà vu, a haunting echo of an earlier encounter that had unsettled astronomy just 2 years before. In 2017, the first interstellar object ever identified had slipped through our solar system, leaving behind a trail of questions that still burns in scientific debate. It was called one ʻOumuamua Hawaiian, for scout or messenger, and its fleeting passage transformed how we thought of cosmic visitors. Oumuamua was a paradox wrapped in mystery. Its orbit declared it was interstellar, but everything else about it refused easy classification. It showed no cometary tail, yet its brightness shifted as though it were shaped like a shard, tumbling chaotically. Some argued it was elongated like a needle, others suggested it was a flattened disk. Its acceleration, faint but measurable, hinted at forces beyond gravity, perhaps sublimation of exotic ices or something stranger. Theories multiplied, from natural shard of nitrogen ice to daring speculations of alien technology. When it slipped beyond reach, it left a scar of uncertainty. So when Atlas reported 3I's trajectory, astronomers could not help but draw comparisons. Here was another interstellar visitor, a successor of sorts, and perhaps a chance to redeem what had been lost with Oumuamua's hasty departure. Unlike that enigmatic predecessor, 3I Atlas appeared more comet-like at first glance, bearing the suggestion of a faint coma and possible outgassing, yet echoes of the earlier visitor lingered. Both objects had arrived unbidden, both had cut across the sun's domain with unnerving speed, and both reminded humanity that the solar system is anything but sealed. The echoes ran deeper than scientific curiosity. Oumuamua had forced a cultural shift. The public was captivated by the idea of interstellar debris wandering near Earth. Headlines spoke of alien messengers, research papers argued across disciplines, and the boundaries between astrophysics and philosophy blurred. The arrival of 3I Atlas reawakened that conversation, this time with the hope of a clearer glimpse. If Oumuamua was the scout, then perhaps this new visitor could be the teacher, offering substance where the first had left mystery. Yet the echoes also carried unease. For every revelation, there was the reminder of how little control humanity holds. Interstellar objects arrive on their own terms, granting us only a fleeting look before vanishing forever. In the faint light of 3 Atlas, astronomers heard the whisper of Oumuamua again. The cosmos is alive with wanderers, and you are only just beginning to notice. Why this is shocking? For centuries, the architecture of our solar system had been imagined as a closed domain, an ordered machine where planets, comets, and asteroids orbited under the steady grip of the Sunday. Even with the vastness of the galaxy in mind, the assumption lingered. The objects that brushed past Earth were local, born here, governed by the same gravitational family. But 3I Atlas, like Oumuamua and Borisov before it, shattered that illusion. It was proof written in starlight that our system is not sealed, but porous, its borders crossed by fragments from other suns. What made this revelation so unsettling was not only the rarity of such visitors, but the sheer improbability of detection. To find one interstellar object in a human lifetime would have been astonishing. To find 3 within just a few years suggested something profound. Either the galaxy is far richer in wandering debris than models had ever predicted, or humanity's instruments were only now sharp enough to pierce the darkness and notice them. Both possibilities overturned assumptions that had long stood unchallenged. The strangeness deepened with the physics itself. Interstellar trajectories demand enormous speeds, velocities so great that no planetary slingshot within our solar system could explain them. For 3I Atlas, its path through the sun's gravity well confirmed its exile. It was not visiting by accident, but as a consequence of vast ejections in some alien star system long ago. To accept this is to accept that every planetary nursery across the galaxy is scattering fragments endlessly, and that our skies are crossed by relics from worlds we will never see. For scientists, the shock was twofold. First, that such objects truly pass among us real, not hypothetical. Second, that each one arrives cloaked in ambiguity. Was it a comet shedding faint gas? Was it a shard of rock, bare and silent? Was it something unknown entirely? The data resisted easy categories, forcing astronomy to admit its definitions were too narrow. In this sense, 3I Atlas did more than extend the catalogue. It pressed science against its edges, whispering that the universe is stranger than the language we use to describe it. Philosophically, the shock resonated even deeper, for to glimpse a fragment from another star is to confront the immensity of distance and time. 3 Atlas may have left its birthplace millions of years ago, long before human civilization rose, perhaps even before Earth's continents settled into their present form. And now, briefly, it brushed against our awareness before vanishing again into the dark. The shock lay not only in its physics, but in its reminder of scale, our lives, our species, our world, set against the slow, indifferent journeys of interstellar stones. The speed of exile. If there was one measure that sealed the alien nature of 3I Atlas, it was velocity. Astronomers are accustomed to dealing with motion planets whirl around the sun at tens of kilometers per second. Comets dive in and out of the inner system with long, sweeping arcs, but the speed of this wanderer told a different story. When its path was reconstructed, 3 Atlas was found to be moving at more than 30 kilometers every second relative to the Sun, a pace no native comet or asteroid could ever achieve without assistance. This velocity was not the product of any planetary slingshot in our system. Instead, it was the echo of an ancient expulsion. Somewhere, long ago, in a stellar nursery that is now unimaginably far, gravity played its merciless game. Perhaps a giant planet tugged it too close, casting it outward like a stone skipped from a hand. Perhaps a close stellar encounter jolted it loose from its cradle. Whatever the cause, it was flung into the abyss with such ferocity that not even the gravity of its home star could call it back. That moment of exile defined its fate: to drift endlessly through interstellar space, alone and unseen, until chance steered it into the domain of another sun. Its speed is a kind of time capsule. To move so quickly across such distance implies an age of wandering millions, perhaps billions of years spent crossing the gulfs between stars. During that odyssey, its surface would have been scarred by collisions with cosmic dust, its chemistry altered by the ceaseless rain of cosmic rays. Yet its heart, sealed in cold, may still hold the primordial fingerprints of the system that cast it away. The velocity, then, is not only a measure of motion but of history, an unbroken line stretching back to an origin humanity will never witness. The sun itself could not claim it. Our star bent its path, yes, curving it slightly as it passed, but could not slow it enough to bind. The speed of 3I Atlas carried it through our system like an untouchable guest arriving uninvited, leaving unescorted, immune to capture. In its wake, it reminded astronomers of the impermanence of opportunity. Observations had to be made quickly before the interloper retreated once again to the quiet obscurity of the galactic dark. To think of this velocity in human terms is almost impossible. At 30 kilometers per second, a person could circle Earth in less than 20 minutes. At that pace, the distance from Earth to the Moon could be crossed in just over 3 hours. And yet, for 3I Atlas, such speed was routine, not remarkable, merely the natural consequence of its exile. Its swiftness mocked human attempts at pursuit, underscoring the gulf between our fragile technology and the effortless momentum of a rock cast from the stars. Thus, the speed of exile was more than a number in a chart. It was a reminder of cosmic violence, of planetary systems that shed their fragments like sparks, and of the endless wanderings those sparks endure. To watch it glide past was to glimpse a kind of eternal homelessness, a traveler propelled by ancient forces, carrying no allegiance, bound to no sun, never at rest. Eyes on the visitor. Once its trajectory and velocity confirmed its interstellar nature, 3I Atlas became an object of immediate, almost frantic attention. Time itself was the enemy. Every passing night carried it farther from Earth, dimmer in the telescopes, fainter in the cameras. Astronomers across the globe acted with urgency, linking observatories into a network of vigilance. Large professional telescopes joined the chase, while smaller instruments filled the gaps, each striving to capture a few more photons before the visitor vanished. The coordination resembled a silent chorus. Observatories in Hawaii, Chile, Spain, and the Canary Islands aligned their schedules, trading fragments of the sky as Earth's rotation passed the target westward around the globe. In space, survey missions and orbiting telescopes contributed where possible, refining the object's light curve and path. Every image taken was a race against entropy. The longer 3I Atlas traveled, the harder it became to distinguish its faint shimmer from the background stars. And yet, in those fleeting weeks, humanity's tools revealed much. Through patient exposures, astronomers measured subtle variations in brightness. These fluctuations hinted at rotation, at irregular surfaces tumbling in space. Spectrographs, though pushed to their limits, attempted to pass the faint rainbow of reflected sunlight, searching for traces of ice, carbon compounds, or silicate dust. The challenge was immense. The object was dim, distant, and hurtling away. Still, the collective will of science pressed forward. To place eyes on such a visitor was to confront our own limitations. Even with the most advanced optics, the resolution was insufficient to resolve shape or surface features directly. All that could be inferred came from the language of light brightening and fading, absorption lines etched into spectra, whispers of chemistry carried across millions of kilometers. The human desire to see it plainly, to capture an image as clear as a photograph, was thwarted. Instead, astronomers were forced into interpretation, extracting meaning from shadows. For the public, announcements of the discovery sparked a familiar wave of fascination. Headlines proclaimed, "Another interstellar visitor," echoing the furor of Oumuamua. Amateur astronomers joined the chase, aiming backyard telescopes and hoping to glimpse the faint speck themselves. In a way, 3I Atlas became not only an object of scientific pursuit, but a symbol of shared human wonder, drawing eyes skyward, if only briefly, to remember that Earth is not the center of all motion. The eyes fixed upon it, however, knew the truth. Their chance was vanishing. 3. Atlas was a guest that would not linger. Every exposure, every data point, was a fragment of a story that would soon be untellable. The astronomers kept watch, knowing that in a matter of months the object would fade beyond reach, leaving behind nothing but a trail of recorded light and unanswered questions. Light curves whisper, with telescopes locked upon 3I Atlas. The story of its nature unfolded not through direct sight, but through patterns of brightness. The object itself was too distant and small to reveal its form outright. Instead, astronomers traced the rise and fall of light reflected from its surface, building curves of brightness against time. These curves, delicate as a heartbeat drawn across paper, carried clues about its rotation, its shape, and the materials that cloaked it. The data showed a rhythm, faint dimming, sudden brightening, a cycle repeating as the body tumbled through space. Such variations are the fingerprints of irregular geometry. A perfect sphere would spin with little change in brightness, but a jagged shard, a stretched cylinder, or a lopsided mass flashes light unevenly as it turns. For Oumuamua, those light curves had suggested an extreme elongation, like a cosmic needle or pancake. With 3I Atlas, the whisper was subtler, but still present an uneven traveler, spinning slowly, its silhouette distorted by ancient violence. More whispers hid within the amplitude of those fluctuations. Large swings in brightness can mean dramatic elongation. Smaller swings hint at more compact bodies. The curves suggested that 3I Atlas was neither needle-thin nor disc-flat, but somewhere in between an irregular cometary fragment, perhaps carrying scars of ejection from its native system. Some scientists speculated that outgassing jets, too faint to produce a visible tail, might have nudged its brightness, momentarily shifting how light scattered across its surface. Yet the whispers were ambiguous. A single dataset could be interpreted in multiple ways: a jagged rock, a rotating rubble pile, or even a fractured shard of volatile, rich ice. In this ambiguity lay both frustration and wonder. Humanity had captured a glimpse, but only a glimpse, of an object that had wandered for eons. The light curves offered a riddle without a definitive key, forcing astronomers into a dance of hypotheses. Still, these faint variations had power. They confirmed the object was no inert pebble drifting blankly through space. It had motion, character, individuality. It spun, it shifted, it caught the sun's light and sent it flickering across our instruments like a Morse code from the dark. The cosmos had written its biography, not in words, but in a pulse of brightness across the void. To the philosophers among the scientists, this whisper carried symbolic weight. The universe does not shout its secrets, it murmurs them, softly, through data that must be interpreted with patience. 3I. Atlas had passed close enough to share a fragment of its rhythm, a fleeting pulse of its existence, before silence reclaimed it. The light curves were its voice, fragile but enduring, archived now in human records. For as long as those records endure, so too will the faint whisper of an interstellar guest. Colors from afar. If brightness revealed the rhythm of 3 Atlas's spin, then color offered a different kind of language, a faint spectrum of hues whispering of its chemistry. By dispersing sunlight reflected from its surface into bands, astronomers could read the faint imprints of what it was made of. Yet here, too, the story was more elusive than clear. Spectroscopic studies suggested a surface touched by both ice and dust, though the balance between them was uncertain. Unlike a bright comet blazing with gas, 3I Atlas remained muted, its signal faint, almost reluctant to reveal itself. Its reflected light carried hints of reddish tones, a coloration familiar to astronomers who had studied objects in the Kuiper belt or beyond. Such hues often come from organic-rich compounds, tholins formed when cosmic radiation alters simple ices over millions of years. If so, then the surface of this interstellar visitor was no pristine shard but an ancient canvas, weathered by eons of exposure to the harshness of deep space. Yet the data resisted easy conclusions. Some analyses suggested volatile ices, sublimating weakly in sunlight, were present. Others argued the signals were too ambiguous, more consistent with a dry, rocky fragment. The instruments were straining at the limits of their sensitivity, pulling whispers of color from an object already fading into the dark. One group proposed a nitrogen-rich surface, another hypothesized carbon dioxide ice. Each conclusion shimmered like a mirage, solid for a moment before dissolving in uncertainty. This ambiguity was not failure, it was revelation. It showed how little humanity knows of the materials forged in alien systems. Our solar neighborhood has its taxonomy: asteroids, comets, icy dwarfs. But 3I Atlas did not fit neatly within those boxes. Its spectrum suggested a cousin to our comets, yet one altered by an entirely different stellar nursery. Perhaps its parent star had burned hotter or dimmer than the Sun, shaping chemistry in ways earthly laboratories can scarcely imagine. Colors, after all, are more than aesthetic. They are fingerprints of formation, the hues of cosmic history. To gaze at the reddish tint of 3I Atlas was to witness the slow artistry of time and radiation painting its skin across the ages. Its surface was not merely rock or ice, but a record. Molecules rearranged by photons, scarred by collisions, carved by the silence of interstellar travel. For the astronomers watching, there was a kind of melancholy in those colors. They were clues without closure, hints without answers. Humanity had caught sight of a fragment of another world, but could only guess at its true nature. From afar, the spectrum sang of chemistry and history, but in a tongue too subtle for us to fully translate. It was like hearing a melody carried by the wind, clear enough to move us, but too faint to grasp in detail. Thus the colors of 3 Atlas deepened the mystery rather than resolving it. They reminded us that the universe reveals itself reluctantly, in hues glimpsed only at a distance, never fully surrendered. And in those shades of red and grey, humanity was forced to confront both its growing knowledge and its enduring ignorance, suspended between discovery and wonder. Dust or ice cloak. As 3I Atlas drifted deeper into the inner solar system, astronomers sought the unmistakable signs of cometary activity. The faint veil of dust, the shimmering trail of gas, the radiant fan of a tail. At times, reports suggested that such a coma, a cloud of sublimating ice and dust, was present, faint and uncertain. At other times, the object appeared strangely bare, as if it carried no cloak at all. This inconsistency became one of the central puzzles of its study. If it were a comet, then sunlight should have awakened it, heating its surface and liberating volatile ices into vapor. These vapors, pushing against surrounding dust grains, would form the classic halo and tail, unmistakable even in small telescopes. Some images of 3I Atlas did seem to show just that, a thin mist, suggestive of activity, yet other observations contradicted it, showing a body with no more adornment than a featureless asteroid. The truth seemed to hover between categories, refusing to land. This ambiguity forced astronomers to confront the possibility that 3I Atlas was not a typical comet at all, but something intermediate, a fragment whose ice had been weathered away by its long interstellar exile, leaving only pockets of volatile material to whisper faintly into space. Or perhaps it was truly barren, its supposed coma an illusion, an artifact of limited instruments, straining to separate its dim light from the background sky. The debate deepened, for the answer mattered. A comet could tell stories of chemistry and formation. A barren shard told a different tale, one of collisions and ejection from an alien cradle. Some speculated that what little activity was seen might come from exotic ices unfamiliar to us, substances more volatile than water that vaporized at great distances. Hydrogen, carbon monoxide, or even nitrogen, each a candidate, each carrying implications about the parent system's environment. A nitrogen surface, for instance, would echo the frosty plains of Pluto, suggesting that 3I Atlas was once part of a distant dwarf planet in another system. If so, then its faint cloak was more than gas and dust. It was the last breath of an alien world, dissipating into silence as it fled. But certainty never came. Every attempt to measure its cloak collided with the limits of resolution, the brevity of observation, the relentless fading of the object itself. 3I Atlas remained a traveler between definitions, both comet and asteroid, both cloaked and bare. This uncertainty was itself a revelation, forcing astronomers to admit that the tidy categories built upon local examples were too narrow for the galaxy's diversity. For the poets among the scientists, there was symbolism in the cloak. Was it not fitting that a visitor from beyond should arrive veiled, half hidden, neither fully revealing itself nor fully concealing? The dust or ice around it became a metaphor. Knowledge shrouded in mystery, truth glimpsed, but not possessed. Humanity could observe, calculate, speculate, but never fully grasp. In the end, The cloak dissolved, leaving the object to fade outward into darkness, and us to wonder what secrets it had carried unseen. Models under strain. In the orderly architecture of astronomy, every new discovery is tested against models' frameworks built from centuries of observation, equations refined by generations of physicists. But when 3I Atlas entered the ledger, those models began to creak. It fit nowhere comfortably. Too slow to shed the flamboyant tails of a classic comet, too erratic to settle into the silent predictability of an asteroid. Its faint hints of gas and dust were inconsistent, its spectral fingerprints ambiguous, its brightness shifts resistant to definitive interpretation. In theory, comets and asteroids are two ends of a continuum, icy bodies from the far reaches that erupt into activity when warmed, and rocky relics that remain inert. Yet 3I Atlas hovered uneasily between them. Some astronomers insisted it was cometary, pointing to subtle outgassing and the slight halo glimpsed around its nucleus. Others argued it behaved too much like a rocky fragment, a piece of planetary crust or mantle torn free and exiled. Each side wielded calculations, simulations, and analogies to local solar system objects, but none prevailed. The data could support both, and neither fully. Even attempts to model its origin story faltered. If ejected from another system, what mechanism had launched it? A gas giant flinging debris outward? A stellar flyby destabilizing a planetary disk? Each scenario predicted different compositions and velocities, yet the observations of 3 Atlas resisted alignment. The object was both too typical and too strange, echoing familiar bodies but never matching them. It was a reminder that models built upon a single planetary system, our own, may not capture the full variety of what the galaxy creates. The strain was not merely academic, it cut to the heart of how science defines knowledge. To place an object into a category is to claim understanding. To find one that slips through the cracks is to admit the limits of our frameworks. With 3I Atlas, those limits were exposed. Even the best instruments, the most careful calculations, left open questions. Was this an icy shard stripped of its volatiles by radiation during its long voyage? Was it a rocky remnant blasted from the crust of a planet in another star's orbit? Or was it something entirely novel, a kind of body never before imagined? For the scientific community, the strain of 3I Atlas was not failure, but invitation. Models, after all, are scaffolding, not prisons. When they creak, it means the universe has shown us something larger, demanding that we expand our understanding. In this way, the object became a teacher, reminding astronomers that the cosmos is not obliged to fit our categories, and that our categories must bend to fit the cosmos. The models bent, the debates sharpened, the data piled up, yet still the object slipped away, carrying with it the answers that might have resolved the contradictions. What remained was the tension, the strain itself, as though the universe had reached out and tapped on the glass of our understanding, reminding us how fragile it truly island. A cosmic refugee. To imagine 3 Atlas fully is to picture not just a lone body drifting through our skies, but a fragment torn from the heart of another world. Astronomers speak of it as an exile, a wanderer cast adrift when its home system could no longer hold it. Somewhere, perhaps around a young star blazing in its early violence, gravitational upheavals sent this shard outward. A giant planet may have tugged too strongly, hurling it into interstellar space. Or two stars, circling each other in a binary system, might have exchanged momentum until a fragment of rock or ice was flung beyond escape. However it happened, the exile was irreversible. To call it a refugee is more than metaphor. Just as human refugees carry the scars of their homeland ruins, memories, fragments of language, so too does this interstellar traveler bear the chemistry of its origin. Its surface is written with the fingerprints of radiation and time, but beneath that, its core may still hold the chemistry of its birth. If we could touch it, drill into it, taste its frozen molecules, we would be sampling the geology of an alien world. Instead, we are left to speculate, piecing together its story from light and motion. The violence that cast it out was not unique. Every star system births billions of fragments. Collisions, ejections, and migrations are the norm, not the exception. Our own solar system has done the same. Countless icy bodies hurled outward into the Oort cloud, some pushed even further into the galaxy's wilderness. 3. Atlas is proof that these expulsions do not vanish. They travel, they wander, and after journeys spanning eons, some cross paths with curious eyes orbiting another star. To think of it as a cosmic refugee is also to think of time. Imagine the span of years it has traveled millions, perhaps hundreds of millions. During that odyssey, entire civilizations may have risen and fallen on Earth. Continents may have shifted, oceans advanced and retreated, yet the refugee persisted, unchanged in its solitude, carrying its silent cargo of alien history. When it finally arrived in our skies, it was not by design but by chance, a meeting scripted only by probability across the breadth of the Milky Way. And what of its fate? This refugee will not settle here. The sun's gravity bends its path but cannot capture it. In time, it will slip free again, continuing its exile into the galactic dark. Perhaps, aeons hence, it will pass another system, unseen, or strike a planet. Burying its story in alien soil, its refugee status is eternal. It belongs nowhere and everywhere, a fragment of one world traveling through the domains of many. For humanity, the presence of such a refugee carries a quiet lesson. We, too, are wanderers on a fragile world, exiled in a way from the warmth of other stars, bound only to the light of our Sunday. To see 3 Atlas drift past is to be reminded that the universe is full of travelers, each bearing stories we will never fully read. This exile among us is not a threat, nor a promise, but a mirror, showing that all existence is, in the end, a journey through vast, indifferent space. Galactic Roulette. To trace the story of 3I, Atlas, is to recognize that its presence among us was not destiny, but chance, an improbable outcome of cosmic randomness. In the crowded disk of the Milky Way, trillions of fragments wander, shards of ice, splinters of rock, debris flung outward by newborn planets or ancient collisions. Each moves under the pull of countless gravities, stars, clouds of gas, passing giants. Their paths twist and bend, invisible dice rolling across galactic time. Most wander forever unseen. A rare few, by sheer coincidence, cross into the domain of another star. The odds of such an encounter are staggering. Our solar system, though vast to human perception, is scarcely more than a pinprick against the backdrop of the galaxy. For 3 Atlas to cross this space, at this moment, within the narrow window of our observational ability, is akin to a grain of sand striking a single seashell on a beach the size of Earth. And yet it happened. The roulette wheel of the galaxy spun, and the ball landed here. This randomness does not imply meaninglessness. Rather, it speaks of abundance. If one interstellar traveler has arrived, and then another, and another still, then the Milky Way must teem with such wanderers. The roulette is not rigged, it is overflowing. Every planetary system is a gambler, throwing fragments outward with every epoch, filling the galaxy with relics of their formation. The emptiness between stars is not barren, but seeded with travelers, most of which we will never know. For astronomers, this realization reshapes expectation. Once, interstellar objects were thought too rare to encounter. Now, after Oumuamua, Borisov, and Atlas, the narrative changes. Galactic roulette is not a fluke, it is an ongoing game, and Earth is a participant whether it chooses to be or not. The discovery of 3 in quick succession suggests countless others have passed unseen. The future of astronomy may reveal dozens, perhaps hundreds, of such guests. And yet roulette is also perilous. To spin among stars is to risk encounters not only with harmless fragments, but with massive bodies capable of devastation. The same randomness that delivered 3I Atlas could, one day, deliver a collision. Though the odds are low, the thought lingers. That cosmic dice roll endlessly, and our world is one among many vulnerable targets. But in the end, the metaphor of roulette is less about fear than about humility. Humanity did not summon 3I Atlas, nor predict its arrival. We merely witnessed the outcome of galactic chance. To see it is to be reminded that we are not central, not chosen, not immune to the tides of probability. We are, like the object itself, participants in a vast game of motion, our lives unfolding against the backdrop of forces we cannot control. The wheel will spin again, more wanderers will come, and each arrival will ask us the same quiet question: are you ready to see yourselves as part of a galaxy alive with chance? Interstellar archaeology. To study 3I Atlas was to open a window into a past that did not belong to our own solar system. Every fragment of light it reflected carried the imprint of another star, another planetary nursery, another cosmic history unfolding far away. Astronomers spoke of it not only as a body in motion, but as a relic, an artifact of formation processes that occurred billions of years ago under alien skies. In this sense, it was not merely an object, but a piece of interstellar archaeology. What does it mean to excavate the past of a world we can never visit? For Earth-bound scientists, it meant treating every faint detail of 3 Atlas as a shard of pottery, a fossil bone, a relic uncovered from beneath layers of time. Its spectral colors were hints of the chemistry in its parent system's protoplanetary disk. Its irregular light curve spoke of collisions that fractured it, or of violent ejection events that stripped away symmetry. Even its velocity told a story, the gravitational sling that tore it from its home and sent it adrift. Each clue was a fragment of a larger narrative, a puzzle with most of its pieces missing. The possibility that such objects carry intact chemistry is especially tantalizing. In our own system, comets are time capsules, preserving ices from the earliest days of the Sun's birth. If 3I Atlas is a cometary fragment, then its heart may preserve the original chemistry of an alien star's nursery. Molecules formed in that distant disk, never altered by planets or heat, may still slumber within. If one day such an object could be intercepted, it might reveal secrets about planetary formation across the galaxy, whether organic compounds arise commonly, whether building blocks of life are universal. Yet archaeology is never complete. Just as ruins weather with time, so too had 3 Atlas been altered by its exile. Cosmic rays bombarded its surface, rearranging molecules into tar-like residues. Impacts with micrometeoroids scarred its face. Radiation darkened its color, hiding what lay beneath. The relic we glimpsed was not pristine, but a palimpsest, its original story, overwritten by eons of wandering. To read it was like deciphering a text whose ink has faded, its words half erased by time. Still, even a damaged artifact has power. The fact that such relics reach us at all suggests the galaxy is full of them, scattered across space like broken shards of long-lost civilizations. Each carries a story beyond our own. We may never recover them fully, but their presence reminds us that our solar system is not a closed archive, it is part of a galactic museum, visited now and again by fragments from other wings of the collection. For the human imagination, the idea of interstellar archaeology touches something profound. To hold in our telescopes a piece of matter from another star system is to confront both our isolation and our connection. We cannot travel to those distant nurseries, but their relics can travel to us. 3I Atlas, then, was more than a traveler. It was a messenger from deep time, bearing silent testimony to the universality of creation. Gravity's faint pull. Though 3I Atlas was unbound to the sun, its path was not immune to the delicate choreography of gravitation. Every body it passed, planets, moons, even the subtle tug of the sun itself, etched the slightest curve into its trajectory. Astronomers tracked these shifts with precision, knowing that even the faintest deviation carried meaning. Gravity, after all, is the universal sculptor, invisible, patient, and absolute. When 3I Atlas entered our system, the sun's pull bent its hyperbolic path, drawing it inward before letting it escape again. That deflection was small compared to the immense speed of the traveler, but measurable. It reminded scientists that even visitors from beyond are not entirely free. They, too, must acknowledge the dominion of the sun, if only in passing. Its course, traced across charts and simulations, showed a graceful arc, a signature of submission before liberation. Jupiter, the giant among planets, loomed as another player in this silent drama. Though 3I Atlas did not come near enough for a direct encounter, even distant giants exert influence. Calculations showed that its path bore the imprint of such possibilities that if it had come slightly differently aligned, Jupiter's vast gravity could have slung it into another course altogether. A few million kilometers one way or the other, and the trajectory of this interstellar guest could have shifted radically. This sensitivity underscores the fragile balance of motion. In celestial mechanics, small differences in approach yield vastly different futures. A near pass by Earth or Mars could have transformed this object's fate, slowing it just enough to capture it, binding it into a new orbit. Instead, it passed on a trajectory that granted no such intimacy, remaining always beyond reach. In this sense, the faint pulls of planets and stars were like missed opportunities, moments when chance might have tethered the wanderer, but did not. Philosophically, the idea of faint gravitational pulls resonates deeply. We, too, feel the invisible forces of our environments, societal tugs, emotional gravities, subtle influences that bend the courses of our lives without our knowing. The passage of 3I Atlas through our system is a cosmic metaphor for this. Forces acting invisibly, gently curving paths that appear free. Nothing in the universe is ever wholly isolated. Even a rock traveling between the stars carries the fingerprints of countless encounters, gravitational handshakes exchanged silently over eons. And yet, despite all those pulls, the exile continued. 3I Atlas was never trapped, never slowed enough to linger. The sun bent it, the planets brushed it, but none could claim it. It passed through, acknowledged the presence of our system, and departed. Its freedom remained intact, its exile unbroken. What remained for us was not possession, but observation, the recognition that even the faintest interactions matter, even when the traveler is gone. The dark energy lens. As astronomers traced the path of 3I Atlas, a deeper layer of speculation emerged, not just about planets or stars bending its trajectory, but about the invisible fabric of the universe itself. At the grandest scales, beyond the pull of individual suns, there is another force shaping the journeys of wanderers, the mysterious agent we call dark energy. Dark energy is not a wind, nor a tide, nor a detectable medium. It is the name given to the accelerating expansion of the cosmos, a phenomenon first measured in the fading light of distant supernovae. It is subtle on human scales, imperceptible across the span of a solar system. Yet for an interstellar object to drift for millions or billions of years, this slow stretching of space itself may be the quiet stage upon which its journey unfolds. The idea is not that dark energy tugged directly on 3I Atlas during its brief passage through our skies. Rather, it is that its exile, its endless trajectory through the galaxy, is only possible because the universe itself expands. Stars drift apart, systems shed their fragments, and across eons, those fragments cross gulfs that widen faster than gravity alone can account for. To think of 3I Atlas is to think of dark energy as the silent lens through which its entire odyssey is framed. Speculative models even ask, could the slight accelerations seen in interstellar visitors, Oumuamua most famously, be hints of unknown forces linked to cosmic expansion? Most astronomers remain cautious, grounding such anomalies in local physics, sublimating ice, jets too faint to detect, or measurement uncertainties. But the questions linger, because every unexplained motion carries the faint echo of the larger mysteries. Perhaps, in the tiniest deviations of these wanderers, we glimpse the fingerprints of a deeper fabric. Philosophically, the dark energy lens transforms how we perceive 3I Atlas. It is not just a refugee from another star, but also a participant in the grand expansion of the cosmos. Its journey is not only across the Milky Way, but across a universe that itself is in motion, each step of its exile stretched by the invisible hand of dark energy. When we gaze at its path, we are also gazing at the structure of reality itself, a cosmos in which nothing is still, not even space. For humanity, this reflection is sobering. The visitor reminds us that we are adrift not only within the galaxy, but within a universe whose edges rush ever outward. Every star, every planet, every fragment, like 3I Atlas, rides on that current. To recognize this is to accept that we are passengers, not rulers, in a cosmos whose most powerful forces remain unnamed, undefined, yet undeniable. Thus, in the faint light of this wanderer, we see not only the relic of another world, but the shadow of the universe's greatest mystery. Dark energy is the lens through which every exile moves, the silent stage upon which every journey unfolds. Artificial whispers. Among the many theories born in the wake of interstellar visitors, one stood apart, shimmering at the border between science and imagination. The suggestion that such objects might not be entirely natural. It was Oumuamua, the first interstellar body detected, that ignited this spark. Its unusual acceleration, its lack of a visible tail, its bizarre shape, all fueled speculation that it might be a probe, a shard of alien engineering adrift in the stars. Though most astronomers leaned toward natural explanations, the question refused to die. And when 3I Atlas appeared, the whispers surfaced again. The reasoning was simple enough. If intelligent civilizations exist elsewhere in the galaxy, why would they not send out messengers? A fragment disguised as a rock could travel for millions of years, silently scouting the systems it passed. To human eyes, it would appear like any other interstellar shard, unless some signature revealed otherwise. And so, each new visitor from beyond became an object of suspicion, a potential emissary of intelligence rather than geology. In the case of 3I Atlas, the evidence for artificiality was weak at best. Its faint coma suggested activity, pointing toward a comet-like body. Its spectrum hinted at natural ices and dust. No unusual signals or sharp maneuvers betrayed machinery beneath the veil. Yet the very act of asking the question mattered. For the first time in history, humanity had begun to treat interstellar debris not only as astronomical curiosities, but as possible artifacts. The cosmos had become a stage upon which both rocks and probes might appear, indistinguishable until proven otherwise. Philosophically, The idea resonates because it collapses the distance between myth and science. For millennia, people have gazed upward and wondered if the stars hid travelers. Now, with real visitors traced across our skies, the wondering takes a sharper edge. What if these are not just fragments, but messages? What if the galaxy is filled not only with the debris of planets, but with the relics of civilizations? Skeptics caution against leaping to extraordinary conclusions. Nature, after all, is inventive enough to produce anomalies without resorting to intelligence. Sublimating hydrogen, fractured nitrogen ice, or unseen jets of gas could explain what looks like unnatural behavior. To invoke alien design is to abandon parsimony, to choose wonder where patience might suffice. And yet, the whispers persist. For every natural explanation, there is the lingering thought, perhaps this time it is otherwise. 3. Atlas did not betray any secrets. It sailed on, silent and indifferent, leaving no evidence of construction, no signal of intent. But the speculation itself revealed something profound about us. The fact that humanity looked at a dim speck from another star and asked whether it might be artificial shows how deeply our longing runs. We crave connection, even in the cold stones of interstellar space. The artificial whispers, then, are less about 3 Atlas itself and more about our own reflection. They remind us that every discovery is also a mirror, showing the hopes and fears we project onto the unknown. Whether natural or not, the visitor became a vessel for our questions about life beyond Earth, a reminder that the search for meaning travels with us, wherever we turn our telescopes. SETI's careful ears. Whenever whispers of artificiality surround an interstellar visitor, the responsibility of confirmation falls to those who listen most intently to the universe, the search for extraterrestrial intelligence, or SETI. With 3 Atlas, as with Oumuamua before it, the faint possibility that it might carry something more than stone or ice spurred a deliberate campaign of listening. Radio telescopes across the globe, sensitive enough to detect the faintest murmurs of cosmic static, were tuned toward the coordinates of the traveler. Arrays like the Allen Telescope Array in California and instruments in Europe and Australia aligned their dishes, combing the airwaves for signals. The search was precise, targeted, and systematic. If 3 Atlas carried a transmitter, even one weaker than the wattage of a household bulb, SETI's ears had a chance to catch it. The results were silence, no unusual bursts, no modulated patterns, no signs of intent hidden in the static. To the instruments, 3 Atlas was indistinguishable from a natural body, a faint reflector of the sun's light, and nothing more. But this silence was not meaningless. It added to the archive of SETI's patient work, building a catalogue of places checked and phenomena tested. Silence itself is data, narrowing the field of possibility. For SETI researchers, the process was as important as the outcome. The arrival of 3 Atlas demonstrated that their discipline could mobilize swiftly, integrating with traditional astronomy to study not only stars, but the fragments that travel between them. The act of listening, even in vain, reaffirmed that humanity is prepared to take seriously the question of life elsewhere, not as fantasy, but as an empirical investigation. Yet beyond the science, there was symbolism. The image of vast radio dishes tilted skyward, straining for a whisper from a passing stone, carries a poetry of its own. It reveals a species unwilling to ignore possibility, unwilling to let a cosmic guest pass without asking the unspoken question, are we alone? The silence may have answered with indifference, but the act of listening was itself a declaration of intent. Humanity had not dismissed the visitor as a curiosity. It had greeted it with inquiry. Philosophically, this moment stands at the intersection of humility and hope. SETI's careful ears remind us that even as we uncover the natural physics of interstellar travelers, we remain open to the extraordinary. Silence does not diminish wonder, it sharpens it, teaching patience, reminding us that the universe is vast enough to keep its secrets for as long as it chooses. And so, 3I Atlas drifted on, uncommunicative but not ignored. Its silence became part of the dialogue between humanity and the cosmos, a dialogue in which the questions speak louder than the answers, and where listening itself is the most profound act. Mainstream hypotheses. Once the silence of instruments and the ambiguity of light curves had settled, the scientific community turned toward natural explanations, models grounded in physics and chemistry rather than speculation. With 3I Atlas, as with Oumuamua, the challenge was not the lack of ideas, but the abundance of them. Each hypothesis illuminated one facet of possibility, yet none resolved the mystery entirely. One camp proposed that 3 Atlas was a conventional cometary fragment, its faint activity consistent with volatile ices sublimating under sunlight. In this view, its apparent strangeness was simply the product of distance and faintness. A comet behaving normally, only harder to observe because of its interstellar speed and fleeting visibility. If true, this would mean that other planetary systems create and eject comets just as ours does, filling the galaxy with icy wanderers. Others pushed for more exotic interpretations. Perhaps 3. Atlas was made not of water ice but of more volatile substances, hydrogen, nitrogen, or carbon monoxide, that vaporize at far greater distances from the Sunday. A nitrogen iceberg, for instance, would explain its reddish hue and faint activity, suggesting that it once belonged to the crust of a Pluto-like world in another star's orbit. Hydrogen icebergs were also proposed, though skeptics argued such fragile bodies would not survive long interstellar journeys. Some hypotheses considered rocky origins. What if 3I Atlas were not an icy fragment at all, but a shard of planetary mantle or crust flung outward during catastrophic collisions? Such an explanation would place it closer to asteroids than comets, a rocky refugee rather than an icy one. The spectral ambiguity left this door open, for its colors did not exclude silicates. Still, others invoked processes unique to interstellar exile. Radiation over millions of years could transform an icy body's surface into a hardened crust of organic-rich compounds, concealing volatile ices beneath. This would explain its subdued activity, a mantle shielding its heart, leaking only faint wisps when fractured by sunlight. In this scenario, 3I Atlas was not unusual at all, only ancient, its surface bearing the scars of time. Each of these mainstream hypotheses shared one truth. They placed 3I Atlas firmly within the realm of natural bodies. No matter how exotic the chemistry, the story remained one of physics and geology, not technology. For most scientists, this was the most satisfying path. It aligned with what we know of cosmic abundance, that stars form planets, planets shed fragments, and fragments wander. The diversity of hypotheses did not undermine this view, but enriched it, showing how wide the range of possibilities truly island. And yet, the persistence of so many competing models revealed the limits of knowledge. Without direct sampling, without a mission to touch or capture such a body, certainty remains elusive. 3 Atlas, like its predecessors, left behind not a conclusion, but a spectrum of plausible stories, each carrying implications for how common and how varied planetary systems may be across the galaxy. In this way, the mainstream hypotheses are more than guesses. They are invitations to expand our imagination, to prepare future missions, and to accept that the universe rarely grants us simple answers. 3I Atlas became not the end of a debate, but its renewal, a reminder that even in natural explanations, mystery endures. What we cannot see. The pursuit of 3 Atlas was a race against invisibility. From the moment it was first glimpsed, astronomers knew they were working under a cruel constraint: time. Each day carried the visitor farther from the sun, farther from Earth, and deeper into the obscurity of interstellar night. Instruments strained to capture its faint glow, but no telescope, no matter how advanced, could bring its shape into clarity. What remained forever beyond reach was direct vision. We never saw its contours, its jagged edges, its craters or cliffs. No photograph exists where one might point and say, "Here is the face of the traveler." Instead, its form was inferred from shifting light, its composition guessed from scattered spectra. For all humanity's effort, the object itself remained veiled, a silhouette moving through the dark. The frustration was profound. Here was a relic from another star system, yet it slipped past our awareness almost as quickly as it was found, leaving only traces in data tables and memory. This invisibility revealed the limitations of our technology. Telescopes can magnify, but only so much. Spectrographs can divide light, but not conjure detail where there is none. The visitor reminded us that human eyes are still provincial, confined to instruments that can only scratch at the vastness. To know more would have required a spacecraft, an interceptor, launched years before the discovery, waiting in readiness. That readiness did not exist. The opportunity was lost. And yet, the unseen carries power. What cannot be imaged directly must be imagined, and in that space of imagination, science often takes its boldest steps. Artists rendered shapes based on models. Theorists debated possibilities. Was it a shard of nitrogen ice? A fractured cometary core? A rocky splinter from a shattered world? Each guess filled the absence. Each attempt to illuminate the darkness gave the object more presence in human thought than its faint shimmer alone could ever provide. The unseen also humbles. For every visitor like 3i Atlas that we barely glimpse, countless others must have passed unnoticed. Objects too faint, too far, too swift to catch an invisible tide of interstellar debris flowing endlessly through the galaxy. What we cannot see may vastly outnumber what we can. And so, the invisibility of this single traveler is not a failure, but a symbol, a reminder that we live surrounded by mysteries beyond sight. Philosophically, there is beauty in this restraint. The cosmos withholds its secrets, not out of malice, but because infinity cannot be grasped all at once. The unseen keeps wonder alive, preventing knowledge from hardening into certainty. To know that there are things we cannot see is to remain curious, vigilant, awake. 3i Atlas, in its brief appearance, taught us that lesson with eloquence. We saw enough to be astonished, but not enough to be satisfied. The rest was left, as always, to mystery. Theoretical scaffolding. If observation could only whisper fragments about 3 Atlas, then theory was called upon to provide the framework, the scaffolding upon which those fragments might be arranged into meaning. Astronomers and physicists turned to the tools of celestial mechanics, relativity, and quantum chemistry, building models that could account for an interstellar traveler's existence and behavior. These scaffolds were not certainties, but structures of thought, erected in the absence of direct touch. At the foundation stood Newtonian gravitation, the timeless equations that describe how objects move under the pull of mass. These laws explained the hyperbolic orbit, the way the sun bent 3i Atlas's path without capturing it. Yet, at higher precision, Einstein's general relativity was required, especially when charting the object's long trajectory across the curved fabric of spacetime. Even a fragment of rock, small and faint, obeyed those cosmic rules, tracing an arc that spoke of geometry more than force. Beyond dynamics, theory reached into the domain of matter itself. Quantum models described how radiation reshaped its surface, turning pristine ices into complex organic residues. Thermodynamics mapped how volatile molecules might sublimate under sunlight, producing faint jets too subtle to see yet capable of nudging its course. Statistical mechanics explained how billions of such fragments could be ejected from a planetary system, their velocities distributed like dice across galactic space. Theoretical astrophysics became archaeology by equation, reconstructing a history invisible to instruments. Some scaffolds stretched further into speculative realms. Could 3I Atlas have formed not in the cradle of a planetary system, but in the raw molecular clouds between stars? Might the chemistry of its surface reveal processes that happen nowhere near suns at all? These ideas were daring, not widely accepted, but they reflected the willingness of science to expand its frameworks when anomalies appear. After all, Oumuamua had already bent models toward the unprecedented. Atlas, though less radical, continued the pressure. Yet theory, however elegant, was haunted by uncertainty. Each equation depended on assumptions. Each simulation required simplifications. Without direct sampling, all scaffolds risked collapse under the weight of future evidence. And this was precisely their role, not to enshrine truth, but to hold questions aloft until firmer answers could be reached. 3I Atlas demanded such scaffolding not as final architecture, but as a necessary bridge between ignorance and possibility. Philosophically, the act of building these frameworks mirrors humanity's larger struggle. We live surrounded by mysteries too vast to grasp directly, so we build structures of understanding, myths, models, theories that let us climb higher, glimpse farther, imagine more. Some will fall, others will endure, but all serve the same purpose: to keep us reaching. Theoretical scaffolding around 3I Atlas may not yet reveal its essence, but it ensures that the visitor will not pass into obscurity unexamined. Thus the object lives on, not only in faint traces of light recorded by telescopes, but in the mathematical architectures it inspired. It is preserved in equations, in simulations, in the scaffolds of thought that stretch between what we know and what we dream. Future missions imagined. The fleeting visit of 3 Atlas left astronomers both humbled and restless. To watch such a traveler slip away, beyond the reach of telescopes, was to feel opportunity slipping with it. From that sense of loss came a vision of readiness, the dream of missions that could one day intercept, chase, or even capture interstellar objects. Concepts began to circulate in scientific literature and engineering labs. One proposal envisioned a rapid response interceptor, a spacecraft that could be launched within months of detecting a new interstellar visitor. It would not wait in a hangar, but orbit the Sun in readiness, a sentinel prepared to pivot toward any incoming trajectory. Equipped with high-thrust propulsion, such a craft could close the enormous velocity gap and fly alongside the traveler, snapping images, measuring spectra, and perhaps releasing probes to sample its dust. Others dreamed bigger. A solar sail, vast and delicate, pushed by photons or lasers, could accelerate swiftly enough to pursue a visitor even after discovery. Unlike chemical rockets, such sails could achieve the speeds necessary to bridge the gulf, though at the cost of fragility and complexity. A future of wafer-thin sails racing after exiles between the stars began to appear in scientific sketches. The most ambitious ideas reached even further. Missions designed not just to intercept, but to rendezvous and return. Imagine a spacecraft capable of matching speed with an interstellar object, anchoring itself to the surface, drilling into alien ice, and carrying samples back to Earth. Such a feat would be historic beyond precedent, humanity's first direct touch of another star system's matter, a fragment of another world resting in our laboratories. It would be interstellar archaeology in the most literal sense. These missions remained theoretical, constrained by budgets, technology, and the unpredictability of discovery. Interstellar objects are rare and fast. Building a craft to meet them is like designing a net for lightning, yet the urgency grows. Oumuamua and Borisov were missed opportunities. 3. Atlas was another reminder. Each visitor sharpens the resolve to be ready when the next arrives. Philosophically, the imagined missions are more than engineering exercises. They reflect a longing to close the gap between knowing and touching, between speculation and proof. Telescopes can whisper truths from afar, but only direct contact can transform mystery into certainty. The dream of intercepting an interstellar traveler is, at heart, the dream of participation, to not merely watch the galaxy's stories pass us by, but to hold them in our hands. In this vision, the next wanderer will not escape unstudied. When galactic roulette spins again, humanity hopes to be prepared with sails unfurled, engines burning, and instruments ready to greet the exile not as a fleeting stranger, but as a teacher whose secrets we will finally read. Interstellar census. The passage of 3 Atlas did more than spark curiosity about a single visitor. It forced astronomers to rethink the galaxy itself as a populated sea of wanderers. If 3 interstellar objects had been identified in such a short span, Oumuamua in 2017, Borisov in 2019, and Atlas soon after then, surely there must be countless others sweeping invisibly through the solar system every year. The question became not if they exist, but how many. Statistical models began to unfold. By estimating the detection rates of current surveys, astronomers calculated the unseen population. For every one object we glimpse, perhaps thousands pass unnoticed, their faint signatures lost in the sky's immensity. The galaxy, they concluded, may contain trillions of interstellar fragments, each one a shard of planetary formation, drifting across spiral arms like cosmic flotsam. The solar system is not isolated, it is awash in a quiet tide of alien debris. This census carries profound implications. If every star system ejects billions of bodies over its lifetime, then interstellar visitors are not rare miracles but routine features of galactic ecology. Some may be icy, some rocky, some coated in exotic compounds unknown in our own system. A few may even carry prebiotic molecules, the building blocks of life, scattered like seeds across the galaxy. To contemplate such abundance is to see the Milky Way not as empty space, but as an archive of stories, each shard a chapter from a world unseen. The challenge is that most of this population is invisible to us. They are small, faint, and fast, their signatures fleeting against the backdrop of stars. Our telescopes can only skim the surface of this ocean. Future instruments, larger mirrors, sharper surveys, dedicated sky-scanning networks may one day map this tide more fully. Projects like the Vera C. Rubin Observatory promise to expand the census dramatically, detecting dozens of new interstellar objects each decade. Philosophically, the census shifts perspective. It reframes humanity's encounter with Oumuamua, Borisov, and Atlas not as isolated marvels, but as early entries in a growing ledger. Each one is a sample from an endless population, proof that the galaxy shares its fragments across vast distances. To know that so many wanderers exist is to feel less alone, to recognize that our solar system is not a solitary island, but a crossroad in a cosmic migration. The interstellar census also humbles. For if there are trillions of such travelers, then our awareness of 3 is only the faintest beginning. We are like early naturalists, glimpsing a handful of species in a rainforest teeming with life, knowing intuitively that what we see is a fraction of what island 3 Atlas, then, is not just a singular object, but a representative, an emissary from a population so vast it defies comprehension. Thus the census continues, quietly expanding as instruments sharpen. Each new detection will refine the count, turning whispers into statistics, statistics into certainty. And, in that growing awareness, humanity begins to see itself not as isolated observers, but as participants in a galaxy alive with motion, fragments, and stories shared across the stars. Statistical surprise. When 3I Atlas was confirmed as an interstellar visitor, astronomers found themselves startled not only by its presence, but by what it implied. For decades, models had predicted that such objects should exist, drifting between stars in unimaginable numbers, yet the expectation was that they would be too faint, too rare, too fleeting to ever detect. The fact that 3 had already been discovered within just a handful of years, Oumuamua, Borisov, and now Atlas, was not merely luck, it was a statistical revelation that forced science to recalibrate its assumptions. If 3 objects had appeared so quickly after our surveys became capable of spotting them, then the true population must be vast, far greater than once believed. Instead of isolated wanderers, the galaxy may be dense with these fragments, as common as dust motes drifting in a sunbeam. The surprise was not that 3I Atlas existed, but that humanity had found it so soon. It suggested that the solar system is constantly intersected by interstellar debris, and that our instruments were only now sharp enough to notice the stream. This statistical shock carried consequences. First, it hinted at the violence of planetary systems. If trillions of such bodies populate the galaxy, then every star must eject enormous quantities of material during its formation. Collisions, gravitational slings, and chaotic migrations are not rare anomalies but universal features of planetary birth. Each fragment, like 3I Atlas, is a testimony to that chaos, a relic scattered across the Milky Way. Second, it forced astronomers to reconsider the likelihood of future encounters. If our telescopes could detect 3 in such a short span, then the odds of seeing more, perhaps dozens in a decade, rose sharply. What was once considered a miracle became expectation. The element of surprise gave way to anticipation. The next wanderer is not a question of if, but when. And yet, the statistical abundance deepened the philosophical mystery. For each fragment we glimpse, countless others pass unseen. How many travelers, bearing the chemistry of alien worlds, have already crossed our skies in silence, unrecorded and unremembered? How many more will drift past in the centuries to come, indifferent to our presence? The surprise lies not in scarcity but in our blindness, in how much of the galaxy's quiet migration still flows invisibly around us. In the end, the surprise of 3I Atlas was double-edged, a triumph of discovery and a reminder of ignorance. It showed that the galaxy is far richer than our expectations, but also that we stand at the threshold of awareness, having seen only the first sparks of a vast and hidden fire. The statistics have changed. The story has grown. What began as anomaly is now inevitability, and humanity must prepare to live in a cosmos where interstellar guests are not strangers, but neighbors constantly passing through the night. Human reflection. When the data had been gathered, when the models had been argued, and when 3I Atlas had already begun to fade into invisibility, what remained was the quiet work of reflection. For scientists, the interstellar guest was not only a subject of charts and calculations, it was a reminder of humanity's position in the cosmos. To witness a fragment from another star system drift past is to be reminded of how fragile, how brief, and how local our lives truly are. For most people, 3I Atlas did not appear in the night sky as a dazzling spectacle. No comet-like blaze stretched across the heavens, no naked-eye beacon demanded awe. It was invisible to the unaided eye, perceptible only through the patient work of instruments. and yet the knowledge of its presence carried weight. To know that something born under a foreign sun was moving silently above us, just beyond reach, was to feel the vastness of the universe press close. It was wonder not of sight, but of understanding. The reflection deepened with contrast. Earth, bound to the sun, has been humanity's only home. Every breath, every word, every dream has unfolded within this one planetary system. And here was an exile, wandering for millions of years, carrying within its atoms the history of a place we will never see. Its passage was like a window cracked open into a room of the galaxy otherwise sealed from us. Briefly, we were connected not through contact, but through presence. Some reflected on the metaphor of exile. 3. I, Atlas, belonged nowhere, tethered to no star. It was neither citizen nor captive, but a perpetual migrant. In this it mirrored the human condition, a species wandering intellectually through mysteries, always seeking belonging, yet always confronted by the immensity of what lies beyond comprehension. The visitor's silence was eloquent, teaching without words that the universe is not made for us, yet still offers moments of profound encounter. For philosophers, poets, and ordinary dreamers, the reflection became personal. They saw in 3 Atlas a story of endurance, the endurance of matter, cast adrift yet still persisting, surviving radiation, collisions, and endless cold. They saw a mirror of their own desire for meaning in the face of indifference. And they saw beauty in the fleeting nature of the encounter, that something so old, so alien, could pass so near and then vanish forever, leaving only memory and wonder behind. Thus, 3 ETLAS became more than a scientific anomaly. It became a moment of recognition that the universe is vast, that our place in it is small, and that even in the silence of interstellar stones, there is a dialogue worth hearing. It reminded humanity that reflection itself is part of discovery, that data without meaning is incomplete, and meaning without awe is impoverished. The object may be gone, but the reflection it inspired lingers, reshaping how we see ourselves beneath the stars. The long farewell. By the time 3I Atlas had reached the far side of its trajectory, the world's telescopes were already losing their grip. Each night, its brightness faded, slipping beneath the thresholds of detection. Observatories that had once fought for precious minutes of tracking time now reported silence. The object had grown too faint, too distant, too swift. What began as a sudden entrance into our awareness ended as a slow withdrawal, a vanishing act played out not in drama but in inevitability. The farewell of such a traveler is unlike the fading of a comet born here. Native comets return, circling back after centuries or millennia, reappearing in our skies like familiar phantoms. But an interstellar guest offers no return. Its arc is one way, a crossing never repeated. To bid it farewell is to accept finality, that this was the only encounter humanity would ever have with this fragment of another star. It would not blaze again in our heavens. It would not yield its secrets more clearly. Its story in our skies had ended. Astronomers marked its departure in charts. Its trajectory extended beyond the reach of instruments, projected outward into galactic space. The numbers told the fate. It would wander indefinitely, passing through the spiral arms, grazing the outskirts of nebulae, circling the galaxy on a course older than civilization. For 3 Atlas, the long farewell was simply another chapter in an exile that would not end. For humanity, however, the farewell carried weight. It was a reminder of impermanence, of opportunities lost, of the limits imposed by time and technology. Some spoke wistfully of missions that might have been interceptors that could have launched, probes that could have tasted its surface. Instead, we were left only with light curves, spectral traces, faint images, A library of data, yes, but no relic to hold, no sample to study. The farewell was not just to an object, but to the knowledge it might have given. And yet, there was beauty in the departure. To watch it fade was to glimpse the rhythm of the cosmos. Arrivals brief, departures eternal, silence reclaiming what had briefly been known. The long farewell reminded us that discovery is not possession. The universe offers glimpses, not gifts, and it is our task to cherish even the fleeting ones. In the quiet that followed, telescopes turned back to nearer targets, and the world went on. But somewhere beyond the reach of sight, 3 Atlas continued its journey, carrying its alien chemistry, its ancient scars, its silence. It did not need our attention to persist. It needed only the endless night into which it vanished with dignity, leaving behind a farewell written not in words, but in absence. Legacy of discovery. Though 3I Atlas slipped beyond reach, what remained was not emptiness, but a legacy, a body of knowledge woven from the observations, debates, and reflections it inspired. In the archives of astronomy, its data now rests. Light curves preserved, spectra catalogued, orbital calculations stored with precision. Each fragment of information is a thread in a tapestry that will outlast the fleeting presence of the visitor itself. The legacy begins with methodology. Every interstellar object observed sharpens our instruments and strategies. Oumuamua had been a shock, teaching us how unprepared we were. Borisov, with its vivid cometary tale, gave us clearer benchmarks. 3I Atlas, quieter but equally enigmatic, forced refinement of detection algorithms and coordination among global observatories. It demonstrated how swiftly the astronomical community can unite, rallying telescopes across continents to follow a vanishing point of light. That readiness is part of its inheritance. Its legacy also lives in theory. Each hypothesis proposed in its wake cometary fragment, nitrogen shard, exotic ice, rocky refugee expanded the boundaries of imagination within scientific rigor. Even without resolution, those debates enriched planetary science, prompting simulations of planetary ejection, studies of interstellar survival, and refinements of models for galactic population. The visitor's silence was fertile, generating new questions and reshaping old assumptions. For the public, its legacy was more poetic. News of another interstellar traveler reminded millions that Earth is not isolated. The galaxy is not distant but present, brushing against us in the form of passing stones. In classrooms, documentaries, and conversations beneath starlit skies, 3I Atlas became a symbol of cosmic connection, a story that carried wonder into lives far from observatories. Its legacy is measured not only in equations but in imaginations stirred. Philosophically, the legacy lies in humility. Crute 3I Atlas reminded us that discovery is not ownership. The universe offers glimpses, and we must be content with fragments. We did not capture it, we did not exhaust its meaning. We simply recorded its passage, acknowledging that some mysteries remain unsolved, and perhaps should remain so, to preserve the grandeur of the unknown. And yet, its legacy is also hope. For each interstellar object we observe, we come closer to readiness for the next. One day, perhaps soon, a new wanderer will be detected early enough to intercept, to sample, to study in depth. When that day comes, the lessons of Oumuamua, Borisov, and Atlas will guide us. Their fleeting visits will not have been in vain, but the necessary prologue to a deeper encounter with the galaxy's emissaries. Thus, the legacy of 3I Atlas endures. It is archived in data, alive in theory, reflected in philosophy, and shared in wonder. Though the traveler itself has vanished, its discovery remains a permanent chapter in the human story. a reminder that we are not alone in the cosmic wilderness, that the universe visits us, even when only for a moment. What remains unknown? After all the charts were drawn, after the last photons of 3I Atlas were gathered, after the final telescope gave up its chase, what lingered most were the questions. The mystery of the interstellar guest did not dissolve with its departure, it deepened. What was its true composition? Was it a fragment of ice or rock, or something stranger, born in conditions alien to our own solar nursery? Did its surface carry organic compounds forged under another sun, whispers of chemistry that might elsewhere nurture life? These questions, tantalizing yet unanswered, became the enduring legacy of absence. Its origin, too, remains a blank page. We can trace its trajectory backward, but only so far before chaos swallows the calculation. Which star cast it out? Which planetary system birthed it, only to abandon it to the void? Did it once circle a giant planet in a distant spiral arm, or was it part of a dwarf world shattered in collision? The object held the answers in silence, drifting beyond reach before humanity could uncover them. What remains is only speculation, fragile scaffolding around a truth that escaped. Even its physical nature lies unresolved. Was the faint activity truly sublimation, or an illusion of faint light curves? Was the reddish tint the mark of cosmic radiation alone, or the chemistry of exotic ices unknown in our system? Each interpretation remains plausible, none commands certainty. It is a reminder that even with our best instruments, the cosmos keeps its secrets when it chooses. The greatest unknown is perhaps not about 3I Atlas itself, but about the population it represents. How many wanderers are there? Are they countless, drifting in every cubic light-year, silent witnesses to the chaos of planetary birth? Or are they rarer, and our quick succession of discoveries merely the result of luck? Without an interstellar census complete, we can only guess. The night sky, vast and indifferent, hides the true answer. And behind the scientific unknowns lurk philosophical ones. What does it mean that the universe sends us such visitors? Are they simply debris, indifferent fragments of stellar violence? Or should we see in them a kind of kinship evidence that the galaxy is a shared environment where worlds scatter their relics as freely as trees scatter seeds? If so, then 3I Atlas was not just a stone in the dark, but a symbol of connection, a reminder that our solar system is part of a larger web of creation. What remains unknown is not a failure of science, but its fuel. Questions drive the search, mysteries sharpen the instruments, and uncertainties open the imagination. 3I Atlas departed without answering, but in doing so it left humanity hungrier, more restless, more prepared for the next encounter. Its silence was not emptiness, but provocation, a challenge to look harder, to listen more deeply, to wonder more boldly. In the end, the unknown is the heart of the story. 380 came, lingered in our awareness, and vanished again into obscurity. What it left behind was not certainty, but mystery, and it is in that mystery that meaning endures. The silence beyond. When the last traces of 3I Atlas slipped into the immeasurable dark, what remained was not the object itself, but the silence it left behind. A silence vast, indifferent, and absolute, the kind that defines the cosmos more than any flicker of light or burst of discovery. To encounter an interstellar traveler is to brush against that silence briefly, to disturb it with our instruments and our wonder, and then to watch as it closes again, seamless and eternal. This silence is not emptiness. It is a presence, the vast background against which stars flare, planets orbit, and fragments like 3 Atlas drift across gulfs of time. In its stillness, we hear echoes of all that remains hidden, the uncounted wanderers, the untold histories, the infinite stories scattered across the Milky Way. The silence is the canvas, and every object we glimpse is but a fleeting stroke upon it. For humanity, the silence is both unsettling and consoling. It reminds us that we are small, temporary, fragile. Our questions, our calculations, even our awe, all of it unfolds within a cosmos that neither notices nor answers. Yet that same silence grants us freedom to wonder. It is the space in which imagination thrives, where reflection deepens, where mystery sustains its power. Without it, the universe would be noise. With it, every fleeting signal becomes precious. The silence beyond is also kinship. 3I. Atlas carried within it the memory of another sun, another place, another moment of creation. By passing through our skies, it stitched a thread thin, invisible, but real between our world and another. That thread now stretches back into darkness, fading into silence once more. But it remains in our memory, in our data, in the philosophical weight of having been touched, however briefly, by something not of here. And so, the interstellar guest has gone, leaving us to contemplate not only what it was, but what it means. It showed us that our solar system is open, porous, part of a galaxy alive with travelers. It reminded us that our instruments are but the first steps toward readiness, that our questions are larger than our answers, that our awe is as much a tool as our mathematics. Above all, it reminded us that silence is not absence, but mystery. A mystery that invites us to keep watching, keep listening, keep wondering. The silence beyond is not empty, it is waiting. Now, as the narrative draws to its close, let the pace soften, the voice lingers, each sentence stretching into calm, carrying you gently from the immensity of interstellar darkness back toward rest. Imagine the galaxy not as chaos, but as a slow tide, vast and serene, where fragments like 3I, Atlas, drift endlessly through a sea of stars. They are not threats nor portents, but quiet reminders of a universe greater than our imagining. Breathe and picture the exile fading into the dark, its red-tinted surface dimming, its path now beyond the reach of any telescope. It sails through silence, unhurried, untroubled, carrying with it secrets we will never know. And yet, in knowing that it passed, that it shared even a moment of its endless journey with us, we find something like comfort. The universe does not ignore us, it brushes against us in these fleeting gifts. The questions remain, but questions are not burdens. They are lanterns, lit in the night of ignorance, guiding us forward. Perhaps one day another wanderer will come, nearer, brighter, lingering long enough for us to reach it. Perhaps one day we will hold in our hands a piece of another world. But tonight, it is enough to know that the galaxy breathes around us, alive with motion, alive with mystery. Close your eyes and let the silence expand. The stars remain overhead, the earth turns gently beneath you, and somewhere far away, 3 Atlas continues its endless exile. We are part of that same journey, carried together across the dark, united not by certainty but by wonder. Drift now, calmly, into sleep, knowing that even in silence, the universe speaks. Sweet dreams.